Okay, so our first example is we're going to find the x values, just the x values of the critical points of the following graph, 2x to the third minus 3x squared minus 72x. So I'm going to annotate my steps off to the side so I have my problem written down, and the very first step that I'm going to do is I'm going to set the derivative equal to 0 and check for maximum and minimums. So step 1 is going to be take derivative. So how do I take the derivative? I'm going to use, in this case, I'm going to use the power rule. That won't always be the case, but in this case it is. I know that because I have exponents and I have separate terms, so I'm just going to bring those exponents down. 6x squared minus, that 2 comes down and becomes 6x to the first, and that becomes just negative 72. So just a quick annotation to myself, that was the power rule. So step 1 is just going to be to take the derivative. Step 2 is actually going to be to use that derivative to find where is there a critical point. So let's find that by setting it equal to 0. So set equal to 0. Now in this case, that's a very easy step. We're just going to make the derivative equal to 0 here. But it's a absolutely crucial step. So now, from here, we know that we need our derivative to be equal to 0 to have a critical point. So our third step is going to be to solve this equation. And I'm going to make a note here, probably by factoring. I can't guarantee that you're going to have to factor to solve these, but factoring is going to be 95% of the time in these. So let's look over here and let's see if we can factor this. It is a quadratic, so I should look for things that multiply to get 72. But before I do that, I should look to see if there's a GCF here, and there is. The GCF is 6. So I can factor out that GCF to make my factoring a little bit easier. Now that I factor, I will look to just factor the inside of these parentheses. So I'm looking for a product of numbers that give me 12. Okay, let's see, what are numbers that would give me 12? 1 and 12, 2 and 6, 3 and 4. But I also need the sum of those to be negative 1. So let's see. They would have to be, the difference, 3 and 4. Because one is going to be positive and one is going to be negative, because that 12 is negative. So let's see. We would need our 4 to be negative. The larger absolute value has to be negative in this case, so x minus 4 and x plus 3. That would give me a negative 12 and a negative 1 if I combine those together. So remember that when we solve these, we could just take whatever's inside the parentheses and set them equal to 0. So x equals 4 and x equals negative 3. So technically, we're kind of done with most of this problem, but it's going to be up to us to really check to see if there's anything else going on. And to interpret this. So x equals 4 and x equals negative 3 are critical points. Not only are they critical points, they have derivatives of 0 is what we just found. So not only are they critical points, I'm going to make an annotation. These are horizontal tangents. So these are going to be maximum or minimum points. So if you think about this, this might be like where it's coming up to its high point or going down to its low point. And one thing I wanted to kind of stress here, think about way back in the beginning of the year when we talked about leading terms. 2x to the third. What happened when we had an odd exponent but a positive coefficient? What did that leading term look like? That's going to be a cubic that looks like this from way, way back when. So really what we found here is that negative 3 is a max and that 4 is a minimum. Just thinking back on what we already know. But right now, all we need to do is just follow these steps. There is one more thing that I do need to check. And step 4 is going to be to check the denominator and set that equal to 0 and redo my process. Now, in this case, I'm not going to do that. Notice how in none of these steps I even have a denominator. That is only going to be when I have rational functions. So example 1, finding critical points by taking the derivative. I used the power rule here, setting that derivative equal to 0 and solving, and in this case I solved by factoring, and I even annotated that that was a horizontal tangent.